Hello, 1, 2, 3, okay. Yeah, as you can see, I'm French. The French team is there also. Huh? No, you are here. Okay. Yeah, there are even Russians. Okay, so I'm Pierre-Philipp. Now I work as a security engineer. Well, all my career long, I was in the IT industry and I was doing IT service as a sysadmin. I was like consultant, but deploying virtualization, clusters, and stuff like this. So I'm not a developer. I'm basically using your great software for the past 15 years or so. And I've been playing with Xen a lot and trying to push it to the limits. Not only Xen, but the whole infrastructure. And this talk is more related to Xen because it takes into account the infrastructure and what you can do with it, in particular about storage. So assuming a multi-node setup, you have a cluster, a Xen cluster. You need to share the guest virtual disks on a shared storage. What kind of shared storage do you use? So who among us is using NFS? Okay, 80% of people, or 83. Who's using a storage area network? You can raise hands multiple times if you need to. Okay, yeah, okay, everybody. Who's using Ceph DRBD, remote block device? Okay. Well, that's distributed storage already by software. So and it's from Red Hat, so and it's coming hard. Who's using DRBD with LinStore? Yeah, the people from Vates XCP-ng, they have the plugin. And so this is also software distributed storage, taking over the SAN market. It's just very small. It's like David and Goliath. I mean, Red Hat is way bigger than DRBD. DRBD is a small company in Austria. And they try to sell LinStore, which is not the best. My talk is mainly about using DRBD without LinStore. Anybody who's using DRBD without LinStore? Yeah, usually it's used for high availability purpose. It's not used for distributed storage. And this talk is about how to use DRBD without LinStore for distributed storage. Anything else? Use some kind of other shared storage, other technologies? GFS2 on top of SAN, yeah, of a SAN, yeah, okay. Yeah, fine, GFS2 has a great performance. SMB? Okay. Yeah, well, it's possible. It's like NFS, it's possible. Yeah, GFS2 is cool. We can even use it on top of DRBD, but we have to use multiple primaries. It's a nightmare. So yeah, better use it with a SAN. Okay. So for the executives who will be listening this talk, there is a business opportunity, I believe, for you, because this is a way we can try to compete with Red Hat. I mean, Ceph DRBD is to me the only large-scale, big, and already present on the market for doing software distributed storage. And DRBD is another way. It's just that the company in Austria to me, isn't ambitious enough. Maybe doesn't have the budget. It's not coming hard on the market. And personally, I don't like LinStore. It's just a bunch of Python wrappers. So I did my own wrappers in Bash or KSH eventually. You need to switch to KSH if you need a floating point. Yeah, KSH 93 from AT&T. So yeah, what is DRBD? Basically, it's just a RAID 1 over the network with active controllers. So it's quite smart principle. You have a volume that you can move from one node to another, and you can even activate it on the two nodes at the same time. This is called dual primaries, and it's necessary during live migration, during the very short period of time where we actually do the switch. And it works by default. Just out of the box, it's magic. DRBD understands when volume needs to be primary or secondary, so it just switches. This I will show during the first part of the demo. and it switches back to secondary if there is no need. So it's kind of cool. It works very well with Xen. I'm not sure it works well with KVM, but with Xen it works amazingly. It should work with KVM also, but I didn't test it. So you have DRBD version 8 included in the Linux kernel for a while, and the Linbit from Austria offers V9. It's a kernel module for Linux, and it has the diskless feature. This diskless feature makes it possible for nodes which don't have any copy of the RAID 1 replica to also reach the volume. So in the end, you can have a fully convergent cluster because all the nodes can reach the same volumes, even so the actual blocks are on different nodes. You can even use it as fully remote distributed storage, like what Red Hat would be selling with Ceph RBD. I guess they can also sell Convergence. Just by using only diskless on the Xen nodes, you would just configure DRBD as diskless, and you would use diskless feature like to receive LUNs from a SAN, like the same. It's just that it's distributed and it's a bit cheaper because you basically use standard servers. You push a lot of hard drives in it, and it becomes a distributed SAN. The main difference is that instead of having a complicated algorithm designed for the needs of Google and Microsoft as usual, we just have something very simple. This is the most simple static manual distribution you could imagine. You have one volume on node 1, which is replicated on node 2. Another volume on node 2, which is replicated on node 3, and it goes around, okay? This is very simple. If you want to have it as such, very static, very brutal, very rock solid, you would have to break the chain between the last node and the first node if you want to scale, okay? But you don't have to. You can also have dynamic allocation. It depends on how you design your scripts. I did only the former, but it's quite easy to do the second one. So dynamic allocation, you would just add another node and start creating volumes on the new node and balance it between the existing nodes. So you see, we already have some kind of algorithm here for doing volume allocation. It means that if we create a 500 gig hard drive on node 4, you divide by 2 because it's RAID 1. So if you have only 2 replicas, it's just RAID 1 over 2 units. And you divide the half of it, so it's 250 gigs, by 3. So you already know when you need to trigger, when you need to scale. In that case, in case of dynamic allocation. So you don't necessarily have to break the chain. So something about the architecture of DRBD and how we do it. Of course, we don't do GFS2. We could, but we would have multiple primaries. So we do single primaries most of the time, and we put DRBD on top of LVM. So actually, the real volumes are managed by SYN provisioning LVM, and the clustering is done by DRBD. So it synchronizes the volumes. The data in the end is the same, but on top of LVM, LVM may deal with its own data differently. It doesn't matter. It's DRBD which handles the cluster. If you had NVM or LVM on top of DRBD, it would be much more harder to manage. You would have to use a clustered LVM. It becomes quite tricky and quite a nightmare. So with DRBD on top of it, it works well. It synchronizes everything. This is a rock-solid configuration. It's production ready. I use it in a POC for the last 2 years or so. It never broke. Why? Because there is no split brains there. It's just a guest lives only on one node. This is where the SYN volume is active. So there is no problem. Even if it breaks, you just reboot. You don't lose the data like here. Even if it's SYN provisioned, the metadata is just on volumes. Now let's take a more complicated scenario. what if we want to play big, like what Amazon is doing with their AMI images? So how could we do this? What technology do we have at hand for this? Sorry, I'm watching my timer. Yeah. Any idea how we could do how we could do snapshots? I mean, use snapshots as virtual disks and not use snapshots as backups like we usually do when we do snapshots. We just want a copy of the old data, so it's copy on write. But we want something different. We don't want to change the current volume. We want to change the snapshot itself and use it as a virtual disk. So we need some kind of differential metadata. How is it possible with LVM? It is, since LVM2, it's possible. So LVM1, the snapshots were read-only. It was only copy on write. But since LVM2, you have read-write snapshots. So you have copy on write if you edit the template, and you have differential metadata if you edit the active snapshot. And it's also pretty rock solid because it's snapshot metadata per snapshot. So it's pretty organized, pretty clean. The thing is that I overcommit everything as much as I can. I'm pushing my proof of concepts as much as I can. So of course I used SynLVM. In the case of SynLVM, it's LVM2, but using Syn provisioning, the metadata became smarter because the problem with traditional copy on write is that if your leaf, the real volume continues to live, you would have multiple copy on writes, and you would just duplicate your data to keep the backups alive. So it has a performance issue if you use it that way. But we don't use it that way. We do the contrary. We use snapshots as active volume, and we rarely need to edit the template. Maybe a little update now and then, but mainly we use active. So we would be fine with metadata per snapshot. And the thing is that with SynLVM, it solves the problem of performance and duplicate copy on write by putting all the metadata on the same place. I will show you. So here, let's connect to node 1. I have a 3-node proof of concept hidden in the middle of nowhere in a small cheap data center. So LVS. So I use SynLVM, and you see here there is loads of metadata here. It's all in the pool, in the main pool. When you do Syn provisioning, you need one logical volume, that is the pool, where all the other Syn provisioned volumes will pick on. And then you see here the origin. So those are snapshots. This snapshot is based on this template. So I have a Debian template, and Debian Sandbox is based on this Debian template. I have DNC51 guest. It's based on Sabotage February template. And this is a bit scary. I must admit, I'm not sure this is production ready because you have too much stuff in there, in this metadata. You have it in both directions. You have the copy on write. You have the differential metadata because both can be active, the template and the guest. And they deal with all the guests at once. So it's ideal. It's like a big deduplication engine, but it's scary. I mean, I'm not sure this is production ready. I would love to test it in a lab. If some of you want to allocate me some hardware, I will benchmark it, see if it rocks, if it's rock solid. But right now, I'm not so confident. It just works for me, but I didn't stress it like crazy. Okay. Yeah, and the little trick. So if you look at my scripts, you will see that you need to force you need to force activation, because by default they are considered to be backups, so they're not active. You need to force activation. So either in lvm.conf, etc lvm.conf, you disable the skip, or when you create the snapshot manually, you add those two arguments to disable the skip. Because by default, it's not activated. A snapshot is supposed to be a backup, but we use it differently, so you need to do this trick. There are two limitations, though. The first limitation is that you can only run snapshots on the nodes which have the template, which the origin that they use as a snapshot. So it makes the allocation of your volumes a bit more complicated, because either you put the origin, the base volume, which is scene provisioned also, on all the, well, it's scene provisioned for me, but on all the nodes, so you can have Debian running on all the nodes you want, or you just allocate. You put 2 replicas, 3 replicas, depending on the node. But it makes the algorithm of the possible algorithm of dynamic storage allocation and distribution more complicated. Okay. So the first limitation is that you need to run this on the same node. You see here also I have a data node. You don't necessarily want only templates. You want maybe to offer a real disk, virtual disk, to the user, and this will live as a normal, not an origin even, just a volume. Okay, scene, but just a volume. And the snapshot, and it means this snapshot here, well, it can only be based on template 2, for example. You see. So this is a limitation. The other limitation is that well, you're not supposed to snapshot a file system that is alive. I mean, so we would have so usually we don't mount the template. The template is just a template. It's kind of idling. But in case you need to update it, you would have to temporarily put your cloud UI in maintenance mode, or at least the creation of new guests of this template. Tell users or put it in a queue like, okay, we are currently updating the template. I don't know. Or you just never update the template. It's also fine like this. But this is another limitation. You cannot just create guests based on templates that you're actually updating. Okay? And it's also, this is also a bit scary, but it's okay. You see, you could have editing a snapshot on one node, on the right node, let's say, and editing the template on the other node. It will be a bit strange because the snapshot depends on the origin, right? But not only LVM is able to deal with the magic on the metadata on its own layer with the metadata in both directions, but DRBD also is able to handle the cluster quite well and handle the LVM volumes quite well. And as crazy as it sounds, it works pretty well. It doesn't break. Even so, you would be editing the snapshots on the right and the template on the left. Still, DRBD makes the synchronization as it should, and so far. But okay, and this is less scary than the previous one. The scary thing is that all the metadata is on the pool if you're using scene provisioning. But well, it's another thing to take into account if ever you want to do such a cluster. So, as I said, there is static allocation. This is what my scripts are doing for now. And there is possible further works doing storage orchestration, like you would dynamically allocate volumes depending on, well, ideally depending on how much space is available on the nodes, how much storage you want to allocate, and/or how much disk input/output is available, how much load. So the least used disk input/output, you create your mirrors over there. Static allocation is great. This is what I have, but it's quite convenient because you know where the data is, and you know which nodes you can shut down and maintain. So if you have a guest living on node 1 and node 2, another guest living on node 5 and node 6, you know that you can shut down node 2 and node 6 without having any risk because all the replication is fine. Now, well, it depends on how much templates you have and how you organize the templates. In the case of dynamic allocation, it will be ideal for performance, but it's difficult to find two nodes that you could shut down. If you have two replicas per template and per snapshot, I would just shut down one because the data is everywhere, so it's difficult to know what nodes you could shut down. You can only shut down one because you're sure there is another replica. Even if you design your templates to have 3 replicas, even so, it will be difficult to find. So some scripts, it could be viewable. We could have a map of the data, but well, it's something to take into account if ever we needed to do this. So yeah, but pretty easy to do. I mean, without linstore, we just look. In that case, if we want to do dynamic allocation for disk space, we just look how the least allocated data in the pool, and for okay, I can show this. So LV display scene pool. Here we have the same data, the big metadata here, like kind of deduplication, crazy stuff, and the data itself. So we just take the node that has the least, we do the same command on every node, and we find the node that has the most space available. Easy. And for if you wanted to do it for disk input output, we just look at the matrix. So it looks like this. Here I have for the last hour. I update. Okay, maybe after the demo there will be more, but you get the idea. You just do a query to your time series database, and you know which node has the least used writes or reads. And you would have to play with not only the algorithm I was mentioning above, that if like you would have an alarm if you're reaching a point where you need to add a node, like to actually distribute it, to balance it. And you would have to take into, if you were to design such algorithm, how much replicas you want to put for every template, or if you want to put it on all the nodes or not. So there are guest templates, snapshot volumes, and data volumes. So you could play with those 3 different kinds of volumes and distribute them accordingly. This is the link for my dirty scripts. I originally put a QR code, but I'm a bit afraid of QR codes. So yeah, demo time, and hopefully we'll get some spikes in the graph. So here we connected to node 1. So here we have a physical volume, the same on the 2 other nodes. One volume group. By the way, this should be able to work not only on LVM and ZFS or OpenZFS, but on any kind of volume management system. It should be fine. And maybe other ones have something better than this crazy metadata engine. And LVS. So here we have different guests running. This is only the guests, not necessarily running, but the volumes which are configured on node 1, which we can see on node 1. Some of them we would see on node 3 or node 2 also, because they are synchronized by DRBD. What guests do we have running actually? So this is what my scripts are doing. So this is the basic listing of the guests, DNC running guests. So we have some guests running on the first node, we have some guests running on the second node, and we have some guests running on the third node, okay? pfSync, this is BSD. NetBSD runs very well on Xen. It's just not live migrable. So I only have 3 minutes. I will not do the live migration. Also, it just works by default. It switches. It switches active primaries very well. Here you see it's primary on node 1. This is a guest, Elastic 8. It's primary on node 1, diskless, so I don't have a local copy on it. And it's secondary on node 2 and node 3. I would just migrate it to another node. You would see it becomes primary on the other one and secondary locally. So it works out of the box. Now, how do I create snapshots? Well, this is how I use my scripts. DNC list slots. So I'm looking for the available minor number, device minor number. The next one is 55. So I need to find the template name. DNC list templates. I will take Sabotage May. So it's Sabotage Linux, a great distribution based on Moozle. Before Alpine Linux did it, by the way. And you would now create new resource. So this is new resource creating a snapshot, okay? Because I know I want to use a template. The other script will be new resource template to create a full-blown volume. So template name, minor is 55. Resource name I don't need. It will take DNC by default as the name of the DRBD resource, DNC 55. And you see it created DNC 55, so it's just a bunch of scripts, okay? But we have the resource alive, up to date on node 1 and node 3, and diskless on node 2. Now, I deploy a guest, DNC, new guest, sabotage, slot 55, and hostname, sabotage, name, hostname, Xen submit. Okay? And it just changes the IP, does the stew stuff, and starts it on the least used RAM on node 3. It has most RAM available. So this is not storage orchestration, but we are going into the world of guest orchestration. But it just starts where there is most RAM available. Okay, 1 minute left for questions. Yes?
Yeah, one question on how you create a snapshot in a consistent way. But I understand that you have 2 replicas on top of SynLVM, and if LVM is creating the snapshot on this node, how do you know that the snapshot on the other node would match?
But I will not create snapshots independently using the command line. I will only use the DNC scripts, the storage orchestration, which necessarily creates it on both.
Okay, so you pause the DRBD layer or ensure the scripts ensure that it's consistent.
I don't pause DRBD, I just create the volumes with the scripts, and then the script also creates the DRBD volume on top of it. So it's designed to be packaged as a cloud solution, not still used as command line and yeah, you can check the scripts if you want. It's a bit dirty, but it works.
What's the resource usage like in DOM0 for DRBD itself?
I don't know. Yeah, I didn't run into performance issues. I didn't measure precisely DRBD. What I can say is it's good enough. It's actually it's supposed to be faster than Ceph. Why? Because there is no hash tables, there is no algorithm. It's just simple. And to me, it makes it more reliable. So it should also be faster.
Did you try to compare different IO requests? Use a solution or without using the solution, just to see what overhead might be in terms of performance IO requests?
No, I did benchmarks between GFS2, putting VM disk on GFS2 versus putting versus doing it on top of SynLVM. I didn't see. I have the results. It's pretty equal, but you're asking if there is a performance overhead with DRBD or without DRBD?
An extra latency that might be measured using some sort of
It's a very low latency. I didn't measure it. I didn't do this benchmark. I didn't do. I could do it, but it's pretty good. It's pretty good. And as I said, possibly much better than Ceph even, because it's very simple. It's just doing RAID 1 over the network. Okay. Any other question? So thank you.